We'll now go over question 3 from exam 1. 3 displacements of an object are shown in the figure, where A is equal to 40.0 units, B is equal to 25.0 units, and C is equal to 15.0 units. And there's a reminder here to set your calculator in degrees. For part A of the question, determine the x and y components for each vector. Well, in the figure, I've already broken vector A, decomposed it into its x and y components. The x component of A is horizontal, and the y component is vertical and positive. A sub x is positive as well. A sub x is the adjacent side of the right triangle, and A sub y is the opposite side. So for part A, the x component of vector A is equal to A times the cosine of 40 degrees. And they tell us that A is 40.0 units. Okay, so that's how we evaluate A sub x, and it's going to be positive. A sub y is going to be, since the y component is the opposite side, then A sub y is going to be sine 40 degrees. And then this evaluates to 40.0 sine 40 degrees. So let's go ahead and put these in our calculator. And when I do that, I get A sub x is equal to 30.6 and A sub y is equal to 25.7. Now for the x and y components of vector B, we see that the x component of vector B, that is the horizontal component, is opposite to the angle this time. If we use the angle 65 degrees, and it points in the minus x direction. So I evaluate B sub x as minus b times the opposite side, so sine of 65.0 degrees. And then looking at the y component of vector B, I see it's vertically and positive, pointing upwards. It's going to be proportional to the adjacent side, and so it's equal to plus b cosine 65 degrees. Then when I evaluate that, I get minus 22.7 units for the x component, and I get plus 10.6 for the y component of B. And then looking at vector C, we see it has no x component. C sub x is equal to 0. C sub y is in the minus y direction, so it's minus 15.0. And those are the answers to part A. Part B, we want to find the resultant vector, r, which is equal to vector A plus vector B plus 2 times vector C. So if we evaluate the x component of vector r, that's equal to the x component of vector A, which is 30.6, plus the x component of vector B, which is minus 22.7. And when we do that, we get that that's equal to 7.9. Evaluating the y component of this sum, that's equal to the y component of A, which is 25.7, plus the y component of B, which is 10.6, plus 2 times the y component of C. So that's going to be equal to minus 30. And then I add these up, and I get 6.3. So writing down the vector in unit vector notation, and my answer is r vector is equal to 7.9 I hat plus 6.3 j hat. Then in part C, we're asked to find the magnitude and the direction of the resultant vector r and the angle that the vector r has with respect to the plus x-axis. So the magnitude of vector r is simply equal to the sum of the x component squared plus the y component squared. And that's equal to 10.1. Then to determine the direction, we always draw the vector. So vector r's x component is 7.9 in the plus x direction and 6.3 in the plus y direction. And this is the x direction here. So vector r is pointing in this direction, and here's status of r. So we see that the tangent of status of r is 6.3 divided by 7.9, the opposite side divided by the adjacent side. So status of r is equal to the arctangent of 6.3. I'm having a hard time with my pen here. over 7.9. And when I evaluate that, I get 38.6 degrees. And that concludes this video.